Hi, my name is Andy. Today we're going to learn a little bit of basic probability using Texas Hold'em, which is a poker variant. If you've never played Texas Hold'em, here's a little overview. Each player gets 2 cards which are their own, and then there are 5 community cards, and each player tries to make the best 5-card hand out of those 7. The way that the 5 community cards are played is there's a round of betting, then 3 come out, which is called the flop, another round of betting, 1 card called the turn, another round, another card which is called the river, 1 final round of betting, and then everyone shows their card and you see who won. So today, for our example, we are going to look at the probability of getting a flush, which is 5 of the same suit, if you have 2 of the same suit in your hand and 2 more come out on the flop. So let's say that my cards are 3 ace of hearts. I'm going to play this hand because I have an ace, which is a very good card, and I have 2 of the same suit. So I'm going to be looking for a flush of hearts. So I bet, and the flop comes out, and just what I was hoping for, I get some hearts. So I now have 4 hearts after the flop. So I'm betting that the turn or the river will be another heart, I will get the flush, and I will win the hand. A flush is a very good hand. So I bet, and the turn comes out, and it is not a heart, which is not good. I didn't get the flush. I've put some money in thinking that I would, but I still have a chance on the river, so I'm going to continue to bet towards the probability that the river card will be a heart, and I will get my flush and win the hand. So I bet, the river comes out, and it is not a heart. I have now put a lot of money towards the chance that it would be a heart, and it did not get me the flush, so I have lost the hand. And now I will show you with mathematics why that was not a smart bet. So, after the flop, I had 4 hearts. I need 1 more to get 5 hearts and make the flush. For the turn, there's a 1 in 4 chance that any card will be a heart, and a 3 in 4 chance that it will be any other suit. And for the river, it's the same, 1 in 4 that it will be a heart, and 3 in 4 that it will not be a heart. So overall, for the entire hand, 1/4 times 1/4, there's a 1 in 16 chance that I get 2 hearts. There's a 3 in 16 chance, 1/4 times 3/4, that I get a heart on the turn and not on the river, but I still get 1 heart and make the flush. Similarly, there's a 3 in 16 chance that I miss on the turn and make on the river, 3/4 times 1/4, 3/16. And there's a 9 in 16th chance that I miss on the turn and I miss on the river and do not make the flush. So overall, there's a 7 in 16th chance that I get at least 1 heart and make the flush, and there's a 9 in 16th chance that I do not get any hearts on the turn or the river, and I do not get 5 to make the flush. You can check your mathematics. 7/16 plus 9/16 should be 16/16, so you have a 100% probability overall. So, it was not a good bet from the very get-go, because overall there was less than a 50% chance that I would ever get the flush. Let's look at a Markov chain version of this. So, if you have the flush, there's a 100% chance that you will continue to have the flush, and a 0% chance that you will go from having a flush to not having a flush. And if you haven't hit it, there's a 1 in 4 chance that you will get the flush, and a 3 in 4 chance that you will remain to not have the flush. The same probabilities put out in a transition matrix. If you have the flush, there's a 100% chance that you will continue, and a 0% chance that you will go from having a flush to not having a flush. And if you don't have the flush, there's a 1 in 4 chance that you will go from not having it to having it, and a 3 in 4 chance that you will go from not having it to not having it. If you multiply 2 of those transition matrices together, 1 representing the turn and 1 representing the river, you get the same probabilities, 7/16 yes and 9/16 no, that we saw above. Now, one more final tidbit of why this was not a smart bet. There are 13 hearts in a deck of 52, so there's a 1 in 4 chance that any random card will be a heart, which is the probability we used above. But, after my 2 cards and the 3 flop cards were played, there are now 47 cards left unknown, and only 9 of those remaining are hearts, because there were 4 hearts already played. That probability is closer to 1/5, which is less than 1/4. So when we used 1/4, we were actually overestimating our chances, and the chances that I would get the flush were even less, so it was never a good bet to begin with.